Good day everyone. Today we are going to see some basics of lines and planes in three-dimensional geometry. These basics only will help you to understand the further models I will be explaining in the videos. So now let me tell you certain basics. All the formulae for the lines and planes I have given as a PDF and I have given the link in the description. Please copy down all those formulae and then if you listen to the video, it will be easy for you to follow. So now I will consider the vector equation of a line. The standard form is R vector is equal to A vector plus T B vector. Here A vector denotes the line passes through a point. The position vector of that point is A vector. B vector is actually the direction ratios of the line, or it can be the parallel vector. Both are same actually, because when two lines are parallel, the direction ratios will be proportional or equal. So here the B vector represents straight away the direction ratios of the line we can take, or it is the direction ratios of the parallel vector. This T is a scalar. This is the vector equation of a line. Okay. Now, let me tell you the corresponding Cartesian equation also. That is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Here, the x1, y1, z1 represent the point through which the line passes. The a, b, c represent the direction ratios of the line. So, this is the vector form and the corresponding Cartesian form is this. First, you should understand clearly when an equation is given, how to find a point, how to find the direction ratios, then how to convert from one form to another. So, these are the things now we will see. Okay. So, now let me consider this equation. R vector is equal to 2i cap minus j cap plus 5k cap plus lambda into 3i cap minus 2j cap plus 4k cap. Okay. So, this is the vector equation of any line. When it is of this form, R vector is called a general vector, which is xi cap plus yj cap plus zk cap. Now, the first, this one, this represents the position vector of the point through which the line passes. Then the second part, this represents the direction ratios of the line. This lambda or t, whatever letter you use, that is a scalar. Now, when I give you this vector equation, you should know it passes through this point. This point is now given in the vector form. You can say the point is 2, minus 1, 5 in Cartesian form. The direction ratio here it is in the vector form. You can say the direction ratios are 3, minus 2, 4. Okay. Once you know the direction ratios, you can easily find the direction cosines, because when you know the direction ratios, you have to use root of that 3 square plus minus 2 the whole square plus 4 square. That will give you the modulus. So, you will be getting root 9 plus 4 plus 16, which is equal to root 29. Now, these are the drs. So, the direction cosines will be 3 by root 29 minus 2 by root 29 and 4 by root 29. So, when your equation is given in the vector form, you can find out what is the point through which it passes, you can find the direction ratios and you can find the direction cosines. Now, let us come to this Cartesian form and let me take one example for this. I will take x minus 2 by 5 is equal to y plus 3 by 7 is equal to z by 2. Here, you have to compare it. This is the format, okay. So, it is x minus 2. This is y minus of minus 3. Here there is nothing, so it is like 0. Z minus 0. Have this in mind. Now, the point x1, y1, z1 here will be 2, minus 3 comma 0. This is important because here it has a plus. We have to write that as y minus of minus 3. Then only it will be of this format. That is important. So this is the point. Then what are the direction ratios here? The direction ratios are 5, 7 and 2. This is the direction ratio. Once you know the direction ratio, in the same way you can calculate the direction cosines. Okay. So the first thing is, now I have given a equation of a line in vector form. From that you can find out the point, the direction ratios and direction cosines. When the equation is given in the Cartesian form, you can find the point, you can find the drs, you can find the dc's. Dc's means direction cosines. Okay. Hope this is clear to you. Now one more important point which I want to say is, when the equation is given in Cartesian form, sometimes you will not have it in the standard form. Let me explain what I mean by standard form and how to convert it to a standard form. Now, let me consider this equation now. 2x minus 1 by 3 is equal to 4 minus 1 by 5, that is equal to 3z. Now, the standard form means, in the formula you have x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Here the coefficients of x, y, z should be plus 1. That is called a standard form. So here you can see the x has a 2, the y has a negation, here the z has a 3. So it is not in the standard form. So how to convert it to the standard form? Now, here take the coefficient of x out. You will get x minus half by 3. Here the coefficient of y is actually minus 1. I will just take the negation out. I will get y minus 4 by 5. Here it is 3z, you write it as it is. Now that is not enough for us. Now whatever be the coefficient we have out, we have to bring it down. So now I will get x minus half by 3 by 2. That is equal to y minus 4 by minus 5, that is z by 1 by 3. This 3 will come to the denominator as 1 by 3. Now, this equation is in the standard form. Then only you can find what is the point, what are the drs. When it is given in this form, you cannot find which point it passes through and you cannot fix the drs by seeing the denominator. Remember, this is a very important concept you have to remember. So here, the point now is, it is half, comma 4, comma 0. The denominator that represents the drs. So the drs are 3 by 2, comma minus 5 and 1 by 3. So now this is converting a Cartesian equation which is not in the standard form to the standard form. Okay. So this is one important thing. You should know how to convert a vector equation to a Cartesian and a Cartesian equation to vector form. Let us see how to do that. So let me consider some equation. R vector is equal to 2i cap minus 3j cap minus 7k cap plus lambda into I cap minus 2j cap. I am not writing any k cap there. Let it be. Now this is a vector equation of any line. Now I am going to convert it to the Cartesian equation. So I know what is the point given here. That is 2, comma minus 3, comma minus 7. This is the point. Now I told you this is the direction ratios. So now the direction ratios are 1, comma minus 2, comma 0. This is the drs. Note it down. Now, what is the format of a Cartesian equation? That is x minus x1 by a, that is equal to y minus y1 by b, that is z minus z1 by c. So now, in the place of x1, y1, z1, you substitute the point. In the place of abc, substitute the drs. So we will get now x minus 2 by 1, that is equal to y minus of minus 3, so plus 3 by b is minus 2, that is z plus 7 by 0. So this is the Cartesian equation of this vector equation. Okay, hope you have understood this. Now let me explain how to convert a Cartesian equation to a vector equation. So let me consider one in the standard form first. So I will take x minus 5 by 7 is equal to y plus 2 by 3 is equal to z plus 5 by 2. Now this is the Cartesian equation of a line. So first let me write it properly. I can write it is x minus 5 by 7. So the format I am getting y minus of minus 2 by 3, that is equal to z minus of minus 5 by 2. So now it will be clear. My point is here 5 comma minus 2 comma minus 5. This is the point because I have a minus in the formula. Then the denominator, that is that 7 comma 3 comma 2. This is the drs and this is the point. So now this point is the position vector of in the vector form. That will be my a vector. So now I will write r vector is equal to, don't forget to write this r vector because it is an equation. You should have an LHS and you should have an RHS. R vector is equal to, you write now 5 I cap minus 2 j cap minus 5 k cap. So the point is over now, a vector, plus put some lambda or t whatever into the dr. You can write as it is 7 I cap plus 3 j cap plus 2 k cap. So this is the vector form of this Cartesian equation. So I think you are now clear about in the line the basics. Now let me tell you just a few basics in the planes now. In a plane also you have many types of equations there, but let us consider the standard one today. Okay, that is I will just consider any equation of the format ax plus by plus cz plus d is equal to 0 represents a plane. This is called the general equation of a plane. Okay, so now let me take one example. 2x minus 3y plus 4z plus 7 is equal to 0. So this equation represents a plane. Here this 2 minus 3 and 4, that is the coefficients of x, y and z. This represents the direction ratios of the normal to the plane. A plane do not have drs. Only a line will have direction ratios. So these are called the drs of the normal to the plane. Normal is any line which is perpendicular to the plane, you call it a normal. So now this 2 comma minus 3 comma 4 is the drs of the normal to the plane. Okay, then the corresponding vector equation I will tell you, that is r vector dot, you can write x r vector dot, you can say some n vector. Okay, we will represent it by n vector, that is equal to d. Here that n vector is the normal vector. It is called the normal vector. So now I can write r vector dot 2 I cap plus j cap minus k cap, that is equal to 7. This is vector form of an equation. Here this 2 I cap plus j cap minus k cap represents the normal vector which is called n vector. Now the standard form in the vector here is r vector dot n cap is equal to d. This d is different from this d. If you want, you can use different letters. Here this n cap is called the unit normal vector. Okay, it is the normal vector, but its modulus will be unity, that is the modulus will be 1. So r vector dot n cap is equal to d. This is called actually the normal form. Here this d represents the perpendicular distance from the origin to the plane. Here that d does not represent the perpendicular distance when you have the n vector. When you have the n cap, that d represents the perpendicular distance from the origin to the plane. Okay, so now the Cartesian form is ax plus by plus cz plus d is equal to 0, general format. The corresponding vector form is called r vector dot n vector is equal to d. Here n vector is normal vector, but the standard form, the normal form which we call is r vector dot n cap is equal to d. Here that d represents the perpendicular distance from the origin to the plane. Let us see quickly how to convert from vector to Cartesian and Cartesian to vector form if it is given in this format. Okay. So now let me consider r vector dot sum 3 I cap minus j cap plus 4 k cap is equal to 8. This is the vector equation of your plane. Now I know this is my n vector, right? So now if I want to convert it into Cartesian form, actually this r vector is x I cap plus y j cap plus z k cap. If you do the dot product, what will you get? You will get 3x minus y plus 4z, that is equal to 8. So this is called the Cartesian format straight away. Actually we are substituting in the place of r vector x I cap plus y j cap plus z k cap. We are doing the dot product, or you simply remember like this 3x minus y plus 4z, that is equal to 8. So this represents the Cartesian equation. Now if I give you a Cartesian equation, 2x minus y plus 5z is equal to 9. If I want to convert this into vector form, first write r vector, okay, put a dot. Then right now this is 2 I cap minus j cap plus 5 k cap, that is equal to 9. So from Cartesian to vector, this is the chain. From vector to Cartesian, that is how you have to do. So I hope you have understood all the basics of lines and planes. So we will continue further models in the next video. Thanks for watching. You can subscribe to the channel and you can click the bell icon to get further notifications.